All right, today we're going to be talking about parallel and perpendicular lines. And in particular, we're going to be talking about the angles that are formed by parallel and perpendicular lines and their relationships to each other. There's a lot of vocabulary in this section, so a lot of it's just about identifying the names of different pairs of angles and then remembering which pair may be equal, which pair might be supplementary, that kind of thing. So to begin with, we have parallel lines. And we define parallel lines as lines that do not intersect. So parallel lines do not intersect. And they're typically going to be presented like this, equidistant from each other. And you may see in the textbook, you may see like a red arrow like that on the lines, and that will show you that these lines are indeed parallel. Again, you always have to be careful going off of a picture. Don't just assume that things are parallel if you don't know they're parallel. So this is to indicate to you that they are parallel. Is there a question about that?
No, I was just asking, you said they're equidistant. What does equidistant mean?
So equidistant means that these two lines are the same distance everywhere along their length. So anywhere you measure the distance between these two lines, like say this is 5 inches, it'll be 5 inches all the way down the line, okay, so to speak. All right? All right, so those are parallel lines. And for our current topic, we're looking at what happens when you intersect these parallel lines with a third line, which I'll draw in purple here. And we're going to call this line the transversal. Transversal is a line that intersects parallel lines. So we can see that it crosses through the lines. Transversal, that language specifically refers to cutting across, going across, all right? So this is the transversal. And we're going to identify some points so that we can name angles along these lines. So we'll call this A, B, C, D, and then E, F, G, and H. A reminder that in terms of the way that we write angles, we can talk about angle AGH, and when we refer to AGH, we're referring to this angle right here. It's always, the middle letter is always the vertex of the angle, and the first and the last letter always refer to the points that lay out on the sides of that angle. So this is AGH right here, AGH, and sometimes in the book you'll see it'll say M angle AGH. That little M stands for measure, the measure of angle AGH. So it's really, this is sort of the geometric description. This describes this angle. Measure of angle AGH describes just the number, the actual measurement of the angle. So it's 23 degrees or 43 degrees, something like that. All right? So we have our transversal, and we have a whole bunch of angles identified. We're going to be looking at different sets of these angles and how they are related to each other. The first one that we're going to look at is angle AGH and angle CFH, or CFG if you like. So this angle right here and this angle right here. We're going to refer to these two angles as being corresponding angles. C-O-R-R-E-S-P-O-N-D-I-N-G, corresponding, all right? And what makes them corresponding is that they lie on the same relationship on this line as it lies on this line. In other words, here you have the transversal cutting across a line, and this is sort of on the upper left side. Similarly here, this is also on the upper left side of that intersection point. So another way to say that is they're on the same side of the transversal and on different sides, the top sides of the two parallel lines. All right, so corresponding angles. And through proof, which I'm not going to do for you right now, we can prove that these two angles are equal. All right, they are equal. So for the purposes of our discussion today, we're assuming that they are equal. And if you look at them, you will see that they do indeed look to be equal. So CFG or CFH and AGH are equal angles, equal angles. So based on that information, now we can unpack a whole bunch of other information about the other angles in this picture, all right? Because we have already, through vertical angles, linear pairs, and supplementary angles, we have all sorts of information that we can use to look at different pairs of angles here. So for example, we know that angle AGH is equal to angle BGF. That would be, I'll color those in red. So this angle is equal to this angle. And if you go back to Mini Lab 1 and look at this intersection of lines, you can see that those are, in fact, anyone know what it is? What kind of angles are they? Vertical angles, right, vertical angles. So those are vertical angles, and we know that vertical angles are congruent, all right, or equal. They are congruent or equal. So AGH is equal to angle BGF. Well, but we also just showed that angle AGH is equal to angle CFH. That was the corresponding angle. And now we know that angle AGH is also equal to BGF, the vertical angle. Things that are equal to the same thing are equal to each other. So you can say that angle CFH equals angle BGF. So another way to say that is that now we know that this angle is equal to this angle right there. And we have a name for that pair of angles. We call them alternate interior angles. Alternate interior angles. What makes them alternate and interior? First of all, they're on alternate sides of the transversal, and they are interior in the sense that they're between the two parallel lines. So alternate interior angles are equal, and just like those two are equal, we would very similarly be able to show that these two, which are also alternate interior angles, are also equal. All right, so in general, we can say that alternate interior angles are equal to each other. Excuse me. Additionally, again, going back to our corresponding angles, let me get rid of some of these extra ones. So if we have our original corresponding angles, AGH and CFH, we can also see that these vertical angles down here are equal. So angle EFD is also equal to angle BGF. No, sorry, not BGF, CFH. So EFD is equal to CFH because they're vertical angles. And again, we already showed that CFH is equal to AGH. So by that, we can prove that angle EFD is equal to angle AGH. So that's a new relationship that we can look at, this angle and this angle. And those angles are, first of all, alternate because they're on alternate sides of the transversal, and they are exterior because they're outside of the parallel lines. One is above it and one is below it. So alternate interior angles, or alternate exterior angles, are also equal to each other. So at this point you may be saying, well, geez, they're all equal to each other, so why are we even making all this distinction between the different angles? Yes?
How are exterior angles formed?
So exterior angles, what makes them exterior is that they are outside of the parallel lines. So if we have our two parallel lines cut by a transversal, we want angles that are on the outside, so those would be on the outside, right? And alternate means that one is on one side of the transversal and one is on the other side of the transversal, like that. Can you see that? And we're saying that those are going to be equal angles. All right, so these two would be equal, and then similarly, those two would be equal. All right? All right, so again, you may be wondering, well, if everything's equal, then why are we even making all this distinction? Well, because they aren't in fact all equal, and we're going to look at a couple that are not. So we've looked at corresponding angles, we've looked at alternate interior angles and alternate exterior angles. Next we're going to be looking at same side interior angles. Same side interior angles. So again, back to our corresponding angles, CFG and AGH, which are equal. If we look at the relationship between AGH, one of our equal angles, and that angle, which is AGF, we see that AGH and AGF are not equal, but supplementary, all right? Supplementary. They add up to 180 degrees. How do we know that? Because they form a linear pair, all right? They form a linear pair, they're adjacent to each other, and they form a straight line, therefore they are supplementary. So therefore, AGF is going to be the supplement of AGH. Well, we know that AGH is equal to CFG, that's our corresponding angles. So CFG plus AGF is also equal to 180 degrees. So we can say in general that same side interior angles are supplementary. Supplementary. So anytime you have two angles that are interior and on the same side of the transversal, so these two and these two over here, those are going to be supplementary to the other angle in the pair. Questions about that?
No.
All right. So in review, let's see, I'll turn around here. So we have corresponding angles, which look like this, and they are equal. We have alternate interior angles, which look like this, and they are also equal. I usually think of them like they form a Z with the parallel line, so it's like if you make a Z, then they're on the two angles of the Z. Alternate exterior angles, which look like this. They're also equal. And then same side interior angles, which are supplementary. One little trick I use when thinking about the same side interior angles. And this also kind of is revealing of some things about parallel lines. I'm going to go ahead and erase our diagram at this point. So if you look at parallel lines and a transversal, looking at these same side interior angles. If you also think about a triangle, any triangle, we haven't covered this officially yet, but some of you may know that the total angles in a triangle adds up to 180 degrees. So if you have A, B, and C, the sum of those three angles is 180 degrees. Well, if you look at these two angles here, if you think about parallel lines as like if somehow they could eventually meet, which they can't because they're parallel lines, but if they could, in a sense, this would be the triangle that they would form, right? It would be 1, 2, 3. Those would be the vertices of that triangle. And you can see already that they add up to 180 degrees. So it's like, in a sense, with the same side interiors, you have two of the angles of a triangle, but they already add up to 180 degrees. So therefore, there is no angle out there in infinity, and it just keeps going. So it's kind of like it's not a real solid proof, but it's just kind of a mind explanation for what that could be like. All right, I'm going to stop there for parallel lines. Tune in for perpendicular lines coming up soon.
Oh yeah. Hey, this is Mr. Buzzard signing off.
This is Mr. Buzzard signing off.